Hello everybody. In the previous video of SN1 reaction of alcohol, I gave you a problem to find out the product. So let's see. Let's look at your answers and match with the answers after mechanisms. So question number 1. So what type of alcohol is this one? So let's begin from there. So how can we determine what type of alcohol it is? Well, the way we can determine is by looking at the carbon atom that is connected to OH group. So in this case, the carbon atom that is connected to OH group is this one. And then we'll look at how many other carbon atom you are connected to from there. So in this case, I'm connected to one on the right and another one to the left. So this one is an example of secondary secondary alcohol. Okay, so this is a secondary alcohol because your carbon atom that is connected to OH directly is connected to two other chains. All right. Okay, so let's look at what would be the product. All right, so let's begin from here. So the mechanism starts the exact same way. So you have acidic proton with HBr, and your oxygen has lone pair, so that's the match made in heaven, right? So they're gonna attract each other's, and then what is the product that you'll be making from this step? So now your bromine will run away with the 2 electrons at the centers. Bromine had already 6 electrons. So what you'll end up making is, so you will end up making something like this. All right, something like this with OH, and we're gonna add extra H from the HBr. So let's color code this one. Oh no, that looks pretty bad. Okay, so we have HBr from there. So we have added a hydrogen from there. So as we go back in our previous video, if you have 3 bonds on oxygen, that would by default will have a positive charge. And when you have 3 bonds, right? Okay, so when you have 3 bonds, you get a positive charge. So next step would be to neutralize the positive charge on oxygens. Okay, so we gotta neutralize the positive charge on oxygen. So let me erase this. I did silly mistake there. Okay, we got 1 lone pair left over. Okay, so if you neutralize it, I'm gonna break this particular bond. You have 2 electrons, so these 2 electrons would move back to oxygen to neutralize it. And let's say what would happen once we go there. So you will end up making so you'll end up making a carbocation because the carbon atom does not have any more 8 electrons. It gave away 1 electrons. So now it has a positive charge. So what kind of carbocation is this one? So you follow the similar strategy. You look at the carbon atom that has the positive charge, and then look at how many other chain it is connected to. It is connected to 1 on the right, 1 on the left. So as a result, you will call this a secondary carbocation. Okay. And what was the leaving group that went away? The leaving group that went away was, I will write here, water. All right. So the water has gone away. So that is our secondary carbocations. Okay. So now when you create the secondary carbocation, we know, is it stable? It's decently stable. Remember the stability of carbocation, tertiary is the better than secondary, than primary, than methyl. So when you created a secondary carbocation, always ask yourself, can we make it better? Can we make it better? Always check this, okay? So if you create a carbocation, can you make it better? What's better than secondary? Better than secondary is tertiary. Well, how can you make it better? This is something happens. It's called 1,2 hydride shift. So I will show you in a second. Okay, so what happened is there should be a hydrogen right next to the carbon atom. So you see there is a hydrogens right here. I'm trying to color code this. So there is a hydrogens right there. And what would happen is this hydrogen will move. So this hydrogens will move with its electron. So it's going to take 2 of the electron and move 1 step near. Remember, if electron moves with the hydrogen, that's hydride. So it's hydride shift. It's going to move to here. And now the carbon atom on the pink here it's not going to have positive charge because it has the octet back again. So that's pretty much what happens. So this is called hydride shift. Again, you start with the hydride. If you don't have hydrogens, then you move the carbon chain, methyl next. And maybe if you don't have methyl, then you move a chain to make the ring stable. That's something you would do. So always check if you have a hydrogens next to the carbocation on the carbon atom next to the carbocation. Move that. If you don't, then move a methyl group. You can move a methyl group as well, but methyl group won't move until if there is a hydrogen. So make sure you move the hydride first. If there is no hydride, then you move methyl. Okay, that's called 1,2 methyl shift. Okay. So let's see what would happen. So we got CH3, CH3, and CH3. And what we did was we moved our hydride from here to here. Now the carbon atom here does not have any more octet. So the carbon atom here does not have octet, so it should have positive charge. And what kind of carbocation would that? This one would be a tertiary carbocation. So you noticed we made our carbocation from secondary to tertiary, and we know that tertiary is better. All right. Okay, so I will just go from there. Okay, let's make this slightly smaller. We will make this slightly smaller and move it out of our way. Okay, I'll put it here. Can we make it better? Okay, so now what would happen is we're gonna take this, and that's your stable carbocation, right? Don't forget we have a bromine minus chilling in our reactions. Don't forget our bromine minus, right? There was a bromine minus here. The bromine was left out. Br minus. So that Br minus is gonna go and attack the positive charge. So what would be our final product? Our final product would be CH3, Br, H, CH3, and H. That is our answers. All right. So a lot of times, so this is the correct. So if you, the common mistake everybody does it is this. H. Okay. They are the Br here. So this one is not correct. All right. Oh, okay. So maybe you can practice a problem with yourself. I will keep the exact same pattern, and you decide the product. Draw the mechanism all on your own and find the product. All right. Let's stop the video here.